Elementary ELA Grade 3, Unit 4, Forces and Magnetism, Distance Learning Packet Week 6. Today, we're going to think about the questions. How are forces created or made? What are the characteristics of forces found in nature? And how do forces improve our lives? We have been learning about magnetism and electricity. We are going to be reading Electricity and Magnetism from Science A to Z and thinking about the question, how is electricity produced and what role does it play in our everyday lives? Let's pause and think about that question. How do you use electricity every day? Do you know how electricity is made? Our vocabulary words for this week include the words generator, electric current, electromagnets, and voltage. Forces and Magnetism, Week 6. So far, we have learned about how magnets work and how we use them to improve our lives. What are some uses of magnets? This week, we will learn about electricity and how it is closely related to magnetism. First, let's watch this video about electricity.
You're totally wasting electricity. I wouldn't do that. Yeah, I'd say you blew a fuse. Ow! Give me some light over here. Dear Tim and Moby, where does electricity come from? From Juan. There are actually two main kinds of current electricity: direct current, DC for short, and alternating current, or AC. Direct current is what you get from things like batteries, fuel cells, and solar cells. In direct current, the flow of electricity always goes in one direction. The electricity that we get through our walls, though, is alternating current. With AC, the current flows in one direction and then switches to go the other way. It alternates back and forth. The switching happens really quickly, 60 times a second, so we don't even notice the lights flicker. If we were somehow able to see the lights in slow motion, though...
Okay, that's enough.
Ugh, it gives me a headache. Electrical energy is made in power plants. In power plants, generators change mechanical energy into electrical energy to make alternating current. Mechanical energy can come from a bunch of different sources like wind, moving water, and burning fossil fuels. Either water or wind or steam from burning oil and coal provide the mechanical energy to turn a turbine. The turbine spins a coil through a magnetic field. This generates an electrical current that changes direction as different parts of the coil pass through the field. Right, that's the alternating current. AC goes from the power plant to a transformer where the voltage is increased so it can travel along long distances and not lose much energy. The high voltage alternating current will run along transmission wires. In some places, transmission wires are high above the ground, while in others, the wires are underground. Before it enters your home, the high voltage current will go through another transformer to decrease the voltage to a safe level. And that's how electricity gets from power plants to our houses. Well, it may seem like electricity is on tap, but that doesn't mean you should waste it. We all have to do our part to conserve electricity.
Great! Did you learn anything new about electricity? What did you learn? Thank you for sharing. Now, let's watch a second video about current electricity, the kind we use in our homes.
Hey, listen to this one. Dear Tim and Moby,
When I touched the doorknob this morning, I got a shock. Why? Why? Sincerely, Amos. Why, that's static electricity. Static electricity is the result of tiny subatomic particles called electrons being pulled from one surface to another. This can happen if you take off a sweater too fast. The difference in electrical charge can cause sparks when you touch a metal object. Lightning is a larger version of the same effect, as masses of air rub against rain clouds. Another kind of electricity, electrical current, consists of a flow of electrons through a conductor. The electrical current powers many things in our lives. These appliances all have one thing in common. They all need an electrical circuit to work. An electrical circuit has three parts: an energy source like a battery or a wall socket, an energy receiver like a light bulb, and an energy pathway like a wire. Electricity flows through the circuit, delivering energy to the light bulb. When electricity flows through an object, a magnetic field is created. Magnets have two poles called north and south. Opposite poles attract each other, while similar poles repel each other. The Earth itself is a giant magnet. Charged particles flowing through the liquid iron core give the Earth a huge magnetic field. That's why compasses point north. Electricity helps us in many ways, but it's good to be careful when you're dealing with it. It can be dangerous, and you shouldn't mess with it. Right, Moby? Moby?
Alright, our first word is magnetism. Magnetism is the power of a magnet to attract, a force that pushes and pulls certain metals. Magnets use a force called magnetism. Alright, let's ask a question. If this side is north, this side must be, that's right, south. North Pole is attracted to the South Pole. But what if there was a South Pole and a South Pole? Would they be attracted to each other? No, the South Pole and the South Pole would repel. But that would still be a form of magnetism. Magnetism is what pushes and pulls certain metals. Our next word is generator. A generator is a machine that turns motion into electricity. Today, generators with large, powerful magnets are used to produce electricity. How do we use electricity produced by generators? We use the electricity produced by generators to
show you one way to make some electricity. Okay? Now, do you know what this is? This is wire. This is copper wire, coiled around. Yeah, lots of copper wire coiled around.
It feels funny.
And I've got a wire connected to each end of that coil, and that goes to this special meter. What I want you to do, Sam, is I want you to put this magnet in and out of this coil of wire. See how it's magnetic? Our table's magnetic. Oh, you got it. Push it in. Look. When you put it, whoa. Look at that. Pull it out. Whoop. The meter goes one way. Push it back in. Goes the other way. Cause and effect. Cause and effect. Do you want to drop it there?
Yeah.
Okay, I'll catch it. Woo! Look at that. When you drop it, it goes one way. And then when it comes out, it goes the other way. When it goes in, you make electricity. When it comes out, it makes electricity. But just being in there by itself doesn't make any electricity. It has to be moving. Yeah, the magnet has to move near the coil of wire to spin a magnet near a coil of wire. You turn the handle of that ladybird. You turn the handle. See the lights on the. See the lights go much brighter. Have a look. Woo!
Our next word is electric current. An electric current is the movement of electrons through matter. They discovered that if a coil of wire is moved through a magnetic field, an electric current flows through a wire. For example, let's look at this battery. You see how this is a copper wire and it connects to this light bulb? What do you think would happen to a light bulb if its electric current was stopped? If it's
with a plastic tape. Now connect the bulb to the cell in different ways. Now carefully look at the arrangements in which the bulb lights up.
As we can see in those cases, the bulbs are not lighting up because it's disconnected from the source. That was positive and positive. We have north and south, positive and negative.
That bulb glows in case of first and sixth. In case of first and sixth, starting from positive terminal of the cell, there is a continuous path for the electricity till it ends at the negative terminal, and hence the bulb glows.
Our next word is electromagnet, a magnet that can be turned on or off and is made by sending electricity through metal. Electromagnets in the generator spin inside coils of wire. Why might you want to turn an electromagnetic on or off? Electromagnets. Our next word is voltage, a measure of the amount of push that gets an electric current going. The transformer greatly increases the voltage of the current. Which would need more voltage to run? A light bulb or a car? Why?
Last video, we learned that electricity is the flow of free electrons between atoms. Voltage is what pushes the free electrons around a circuit. Without voltage, the free electrons will move around between atoms, but they move around randomly, so they aren't much use to us. It's only when we apply a voltage to a circuit that the free electrons will all move in the same direction, causing current. It's easy to imagine voltage like pressure in a water pipe. If we have a water tank completely filled with water, then the mass of all that water is going to cause a huge amount of pressure at the end of the pipe. If we have a water tank that's only partly filled, then there will be much less pressure in the pipe. If we open the valve to let the water flow, then more water will flow at a faster rate from the high pressure tank compared to the low pressure tank. The same with electricity. The more voltage we have, then the more current can flow.
A bigger battery.
Voltage can exist without current. For example, we can measure the pressure in the pipe with the valve shut with no water flowing, and from this we can tell that the pipe is pressurized. What we're really measuring is the pressure difference between what's inside the pipe compared to the pressure outside. The same thing if we have a battery connected to a circuit with an open switch. The voltage is still present, we can measure that, and as soon as the switch closes, it's going to push the free electrons around the circuit.
Today we will also do our first read of electricity and magnetism. As we read, I want you to keep this question in your mind. How is electricity produced? And what role does it play in our everyday lives? So that's pretty much it for day 1 content vocabulary. Make sure that you read the word and the definition, examine the picture, write a synonym, and explain your understanding. Example, if your word was magnetism, you would define it in this box, draw a picture, get specific. This might remind you of a time that you used the word magnetism in your everyday life, and use it in a sentence. Let's look at another one. Generator. Think about a time that you might have used a generator. Do you have any machines that use electricity and have a motor? That might be a generator. Can you use the word generator in a sentence? Let's do the same thing for electric current, electromagnet, and voltage. Thank you for joining us for Grade 3 Distance Learning Week 6 Forces of Magnetism Day 1. Bye!